Okay. There we go. Access control lists. Main objective actually started from there. Right, so what you're going to learn about today is what access control lists are, and they are pretty much self-explanatory. How can we get permissions for different types of users managed through a operation using the routers? Okay, this is what's going on here. So we're going to learn about how to operate an ACL and how we're going to configure ACLs to do something called traffic filtering. I'm also going to introduce an idea called wildcard masks, which I have mentioned before to you, which is the same as a subnet mask, but it's the inverse, yes, that's it, inverse of that. So it's being able to create a flip side of a subnet mask. And then how we configure standard ACLs to secure access and also VTY, terminal access too. So there'll be some scenarios you're going to come across now as to why we need to do this. There we go. So an ACL, access control list, is a series of commands that control whether a router forwards or drops packets based on information found in the packet header. Okay, they're not configured by default. There are no ACLs at all set up on a router to begin with. It's something you apply thereafter. What they can do is they can limit network traffic. So for example, you could say you don't want video traffic to go beyond a certain branch of the network at all. You want it to stop somewhere. Okay, you also can get something called flow control.
Can you filter like a certain amount you want to come and a certain amount you don't want, so you can control certain traffic?
Yeah, very much so, and pinpoint it also, even down to the device level with IP addresses. So we also can do flow control, which means that flow control is just going backwards and forwards and routing updates, sending things in both directions. So we can change that also. They can verify that updates are from a known source only. They're also great for security. So it's also a security measure. This is a networking security thing. You can block a host or an entire network from accessing another network. You also can filter, a great thing about filtering on traffic. So you can say, I only want telnet traffic here and nothing other than telnet traffic. You also can permit and deny services. So I can say, I don't want you to have web access to one group of users, but I don't want you to have FTP access to another group of users. I can do that kind of controlling that way too. Little diagram here showing you this, what an ACL is, just to sort of illustrate that concept. What's happening here is this router has been configured to allow incoming email, but deny incoming telnet, as it is a router after all. Okay, they're saying no need for remote connection. I'm doing it all on local, therefore I don't even want a remote connection on it. Great security measure, just disable telnet in the first place. Over here, I don't want HR to access, beyond this point. So the HR subnet is over here, where they can do things. But below this PC here cannot. Deny means do not allow updates, FTP or web services on this machine here. It's being denied. Okay. The opposite of deny, by the way, they're saying the word allow, but actually the word is permit. Okay, so permit and deny are the two interchangeable config commands you're going to use. The next thing is here, you've got deny video to S1, but deny access to S2 for S1. Okay, so it's a very specific permission again for enabling. So how does this go on in terms of what's going on with the OSI layer, what's really going on behind the scenes? Really, layers 3 and 4 is where packet filtering works, both the network layer and transport layer. And what an ACL looks like, if you ever look at it, it's just literally a list of statements that contain either permit or deny, and these are called ACEs, access control entries, or /ACL statements. So if you've got what you do is you get an interface, you choose your interface, and you say, right, I want to do some configuration of ACL on this. So when traffic goes through that interface, the router compares the information within the packet header, against this access control entry in sequential order. And this is to determine if the packet matches one of these access control lists. That's packet filtering. It can analyze incoming or outgoing packets, and it can occur at layer 3 or 4. You always have in an ACL a final statement, and that's called an implicit deny. Okay, that means it blocks all traffic at the end of it all. So we're trying to say block all traffic, but permit this and deny that. It's another, again, a strong protocol. Yeah, and it blocks traffic outside of those rules. And because all ACLs should have at least one permit statement, it requires at least one permit for it to work. Okay, you can't just do blocks. You've got to have a permission also to get into things. Okay, ACL operation, inbound and outbound ACL. So again, it's applied on the interface. Therefore, there's an ingress interface and an outgress interface. The inbound ACL filters packets coming into a specific interface before they go to the outbound interface. Okay, so it's like a pre-thing. And an outbound ACL filters packets after being routed, regardless of the inbound interface. So it can come from any channels, but this is the way out. Okay, so you tend to configure it in both places.
So whatever packet is not allowed can be dropped, or do they get the sender? Do they get the receipt or anything? Warning or anything?
Sure, yeah, you do get feedback if something hasn't reached its destination. Depends on what you're using though to do that tracer T or pat ping. You know, the kind of feedback we get. There's also a syslog, which is what shows you like a monitoring of what is failing and not failing and being committed. It's being tracked somewhere. So you even can look at a record of what didn't work or who tried to do what, yeah? That's a good security measure. All right, so ACLs can be configured both inbound and outbound, as this diagram here shows. And there's then a little demonstration in packet trace. This is quite a straightforward demonstration. What they show is, they show how an ACL prevents a ping from reaching hosts on the network. Yeah, and then when the ACL is removed from the configurations, the pings are then successful. It's a small packet tracer activity there. Okay, remove access control list and repeat test. I'm going to choose some activities with you shortly. I'm going to choose the best ones, like the most relevant, I think. That one takes about 12 minutes to do this one. 12, 15 minutes, a short activity. Just shows you how it works. So let's look at something called wildcard masking now. IP version 4 ACEs require wildcard masks. So this is a string of binary digits, 32 again, like any mask is. And the router uses this to determine which bits of the address to examine for a match. Okay, and they're often referred to as also called an inverse mask, because where subnet masks where 1 is a match, okay, in wildcard masks 0 is a match instead. Okay, just remember, whenever you're doing ACL configuration, your subnet masks, and you come across that question anywhere, you're flipping it around. 0s are the match, not 1 anymore. Yeah. So there's a little example down here. Normally, to do this, right, we would have done, you see that at the back there, Kamara, can you see that? Yeah, 255 is right. Normally this mask is like 255.255.0.0.
Class B.
Sorry?
Class B.
Class B, yeah, good. Normally it's that, right? And it's like 255, you've got your 1s there and your 0s afterwards, and then you do your matching, and then you get your 1s following. So you would get 192.168.0.0, okay, if you're following it down, right? So if you're now doing it with an inverse mask, what we're doing is we're just reversing that order. Where the 1s were become 0s, and where the 0s are become 1s. Okay, that's how we apply this wildcard mask, which gives you a resulting IP address of that in this situation. There are some more examples that are going to illustrate this in a minute. Here's some examples of types of wildcard mask. This is saying, rather than match, it's actually now saying ignore the last 6 address bits, or 4 address bits, or everything is all 1s. Okay, that's the wildcard masking. Some other examples here. There are other wildcard masks. The standard ones are all 0s. Remember the old, all, everything, and nothing, the 2 extremes. So we've got this kind of like 1-1 here, and a wildcard mask is applied to everything. Okay, yeah. So let's explain what those things mean. This is the inverse. So normally it'd be 255. What normally happens if you do 255, 255 across the whole lot? What's that going to look like, the result? Is that right? If you apply a full all ones there, and you do a wildcard normal subnet mask.
Subnet mask should have some.
But if it's all ones, it's normally all ones, right? The subnet mask standardly. If I applied that to this IP address, what's the outcome going to be? If that's all ones, what do you usually do? Imagine that was all ones. Yeah, you just match, don't you? 1 and 1 makes 1, 1 and 1 makes 1. That's normally what's happening here. All it's doing is just flipping it in reverse. It's confusing like anything. Why have this? I didn't wonder why they do this approach. There's some mathematical reason for it. But this is applying the subnet mask as if it is all ones. Look at the match below there. That's the exact match of that. Yeah? It's just written in a different way. IP address here below that is now all 255s. Here now it's reverse. So usually it's all ones. You get that, don't you? But here, this is now giving you everything as 0.
Why is that?
It's an algorithmic thing. It's like they've tried to use the way that you're doing access control lists. Okay, it's just flipped around. It's just flipped to reverse. Yeah, they see it as a kind of an efficiency. You know, using this kind of idea of having masking. Yeah, inverse masking. You'll see now in the other example what's going on here with this. So practice says here, okay, it just says there's 3 examples. So this one, the first one stipulates every bit. Zeros means every bit, okay, would match. And there's your examples there as well. There's another example. That's like 255.0.0.0, right, to get that. That's what that would create. So some examples of calculating how you calculate the wildcard mask. All you do is you get your normal subnet. There's some examples of it. Okay. If you want to permit access, permit means allow, okay, to all users in the 192.168.3.0 network with a subnet mask of that, it's a normal mask. What you do is you subtract that subnet mask from the full subnet number, giving you that remainder, okay? And that result is something like this in that situation. If you want to permit access for 14 users in this subnet, a /28, and you know that is a 240, right? So you're going to convert what that is to an IP address. That's what you're going to calculate. And if you're doing an access control list, what you do is you take your subnet mask, subtract from 255, and that's the result you're going to get. It's just to remember that pattern. Finally, you want to match only this network and that network with this subnet mask. Okay, here. Again, it's subtracted from 255. And you're going to get 1.255 there at the bottom. That's your result there. There's 3 examples provided. There's some ways to save time. A wildcard mask, which is of 0.0.0.0.0, okay, can be replaced by the word host. Okay, that substitutes for the 0.0.0 mask. And any substitutes for the 2555 mask. So you can use the word any. So if you want to match, for example, that address, you could use this with that, or you can say host, this word here. Similarly, if you're matching 0.0.0.2555, you can use the word any by itself. There's an example there, these 2 wildcard masks. Host is match all bits. Think of that as being like all ones, yeah? All ones across.
So you could just put IP address any.
Global, yeah, any. You'll see some examples in a minute when you do your practical. This ignores all address bits. This is everything ignored. This is match everything. This is ignore everything. So ignore everything is any, and match everything is host. You just correlate, just memorize that and that one. Host and many there. Okay. So there's some examples of wildcard masks. Okay, this is showing how any can be used to substitute the IP address with that wildcard mask of everything. Okay, so you see here that access list 1. By the way, access control list, you'll see how this command, this is a kind of the number of the access control list. You give them a sequence number. Permit, which means allow. That's the IP address being provided. Yeah. Everything being, is it matched or ignored? Yeah, match or ignore.
First one is match.
Yeah, that's host. And any?
And there's the host.
Yeah. Any is ignore, right? This one here is associated with ignoring. So here you go, that one there. And below that's how you write that statement. You save some time by just writing any for all of that. Stuart was asking. Yeah. And below it is access list 1 permit. This is the host one now. So what you do is you simply replace 000 with the word host, and then the IP address follows from that. There's 2 commands there. Okay, now when you're creating ACLs, there's some general guidelines. In terms of how many you could have applied, how many ACLs you could have in total. Say you've got 2 interfaces here, okay, and 2 protocols also running, IP version 4, IP version 6, also on here. So you've got 1, 2, and you also got the IP version 4, IP version 6 there. Ingress and out, in and out there. You could have a total of 8 separate ACLs could be applied. Okay, and why is that? You have 1 ACL per protocol, so you have a separate one for IP version 4 and IP version 6. You have 1 ACL per direction, whether it's in or out, and 1 ACL per interface, gigabit Ethernet 01 or 00 or 01. In this example of a 2 gigabit interface device here. Okay, so it's 1 per protocol, per interface, and per direction. That's how ACLs are written. This could have a maximum, therefore, of 8 lines of sequential listing. So here's an example. So ACLs, a firewall is a good example of this. Firewall is a great security device. It sits on the border of your environment, network environment. And it's an ideal place to put in a type of access control list. So the college one here, for example, we have a router on the edge, and we'll put on some ACE saying we want to block incoming traffic from outside unless it's from these particular sources. That's an example. Yeah. So the external network, the internet, is a big one to consider protection from. Now also, you can use ACLs on a router positioned between 2 parts of your network. So say you've got network A and network B. You can control traffic that's entering or exiting that particular network. You can do it on something called border routers, yeah, and they're on the edge of the network, and they give you a buffer from the outside of the network, you know. And then you also have ACLs for each network protocol. So if you've got a more modern network with IP version 6, you also then need to think about having something for that too. Best practices for ACLs. It really should be based on the security policy of the organization. That's the guidelines given here. A little bit. You give a description of what you want your ACLs to do. So you always put some text in. You say, no, this is the ACL for this. Just some information for yourself, like a bit of code in there. You can use a text editor. It's efficient. In your skills test, this time round, I'm going to encourage you to use a text editor to write your ACLs and your commands, and then copy and paste them and then modify them rather than having to each line by line write the command list. Yeah. So that way you can save time that way and have text files that do standard configurations for you instead. And finally, to test your ACLs on a development network before implementing them on a production network. Okay, it's also help you do like local packet tracer is ideal for that. So following your security guidelines for organization, avoid description. So this will help you understand what ACLs for what, because you can easily lose that in the mess of it all. Create a library of reusable ACLs, and there's also then available online, some of these things. And the issue of like preventing testing beforehand on packet tracer means that you just simply implement live onto the rule structure and no costly errors occur. Because those mistakes can be very much a problem, downtime, poor network performance, and troubleshooting. So going further, the guidelines, one of the key things about ACLs is where do I place an ACL, where do I position this ACL? Okay, where does it exactly get put? And normally, there's some guidance about where they should go in relationship to the kind of traffic they're preventing. So you can choose whether inbound or outbound is appropriate. if you put it in the wrong place, you can really make it a hindrance to better traffic flow. Okay. So the question you ask yourself is, where is it most efficient to place an ACL? So here's some two things to understand for you. An extended ACL is usually placed near the source of the traffic to be filtered, where it's coming from. Okay. So where traffic's coming from, you put an extended ACL there, which prevents undesirable traffic as close to the source without it going anywhere further. You can imagine like there's a troubled region, yeah, and you put your ACL right over that area. It's better you put it at the root of the problem rather than letting it branch out into all over the place and having then 10 ACLs everywhere else to stop that problem off, right? So wherever it's undesirable traffic, a potential risk is going to occur from this place. Like say, I don't know, if I'm being cheeky, but say student network is probably more risky than the staff network for us, yeah? Okay, so we put an ACL near that point of access, that source instead, yeah? Okay, now standard ACLs, okay, a little bit different. They are better to be placed near the destination. So they don't specify ACL's destination addresses at all. Therefore, they don't say this is where things are going to go to, so therefore they're placed nearer to the destination and as close as possible. Okay, you'll see kind of more reasons as to why as we go through the practical on this. As an example, okay, to illustrate now. So what we want to do here is we want to block all traffic from, sorry this is so tiny, block all traffic from 192.168.10.0/24 to 192.168.30.0/24. Okay, that's the kind of block I'm doing. Let's find out my diagram. Where's 10.0/24? Down here, right? That's it there. Okay. And I'm going to block stuff from here to 30.0, which is over here. See that? Okay. So we don't want things going down this line all over here. See this little picture, this little funnel here? Yeah, these are the inbound and outbound ACLs. That's what they indicate. This one particularly here will say filter traffic from 10.0 only to 30.0. A bit weird actually. Filters traffic from, yeah, so it takes it out. So it's saying not allowing this stuff into there in this direction. Therefore, you apply that to G00 interface of that S3 switch. Right, router, I mean. There's that router there that's configured. Okay? So it's blocking that stuff coming into this line here through that chain. That's what we want to protect this device here, right? Then, here's another example. This filters traffic from all these places, okay, reachable by R3. So if this is the blocking of this line here into this one is reversing that. The stuff that goes back up, okay, wherever R3 can reach, okay, it's also filtering that traffic too. So all destinations reachable by R3, R3 can reach all that stuff. Okay, and this is applied on this point. Yeah. So let's explain, like, elaborate this now on this bit of text next to it. So if I wanted to do this particular blocking, there are two places to configure the access. Okay. So it's giving you two options there. So if the access list is applied to the S001, it will block traffic to this network, but also going to that network. So if I put it there, the problem with that is, if I place it here, is not only will it block this line, which it needs to do, it also will block that line, so we don't want that. Okay? Therefore, we apply this instead there, which means that we can go down this line and have block only going there and allow traffic to move freely everywhere else. Okay, so I either could have done it here or here in this situation. So it's applied to this. Okay, and this is where we do the ACL command. So packets can still reach the destination if they need to. Okay, so this one is showing I'm blocking all that lot off from whole lot from appearing to site B. And really, this is where I want to do it. Does that make sense, folks? Yeah. Okay. So standard ACL commands and how do they work? This is before you do some configuration yourself. Numbered standard syntax for ACLs. This is how it's done. These are the various parameters and the various commands you can do. So access list number, you always number your ACL. Remember I showed that one earlier, at number 1. You always name your ACL and give it a number. Okay? And this will help you reference it also. There are ranges, decimal 1 to 99 or 1300 to 199 for a standard ACL. That shows you whether it's extended or standard ACL. Standard is in this range and normal is in this range. Extended here and standard this one. So deny, access if conditions are matched. Permit, access if conditions are matched. Remark is your little description that you add. Okay, you can add a remark about entries in the IP access list to make it so you can find stuff. Oh well, log on, buddy. Right, and we're on chapter 7. Go to look up this where we are now on standard IP version for ACL. Yeah, and I've got a video of this anyway, so you can watch it back. Okay, go for it, Paul. You said charge your phone. Remember behind you, yeah? There's a place there. What you do, you get that floor panel up. Best thing to do is Mickey's bike thing, yeah? I used to put the phone in and just train it over there, long trips on it. Is that right? Only Mickey will see it, actually. Yeah, just keep it out, or put a chair behind you or something like that. That's not bad. Get a chair, maybe rest on there. You can, yeah, if you can fit the phone there, yeah, it's written on steps on the Right, okay. So we have here deny permit remark, source, number of network or host from where which the packet is sent, and you can specify it with that normal 4-dotted format, and use the wildcard if needed as an abbreviation for a source and source wildcard. Okay, log allows you to log, as Purvi was asking earlier, can you check what's going on, right? So you just apply the log word, and that will give you kind of a bit of information about what's going on. It goes in the logging console, and it tracks what's happening in that one. This will show you whether the ACL number, what that ACL number was, that reference number, whether it was permitted or denied, source, and the number of packets. 5-minute intervals, or the first packet that matches. Okay, is where you're going to get the kind of updated. So what we're going to do, we have to sort of learn some of the commands now. And the global configuration command access list defines a standard ACL with a number in the range 1 through 99. That's your standard ACL. Okay. Here's a sort of command. It looks like this: access list number, deny permit remark, source, wildcard, and log. To remove it, the global config command no access list is used. And then show access list verifies that it has been removed. You can do it even after you configure it to check it's all in all right. So here we go, some particular commands now being applied. Here, an example is shown that matches any address that starts with 192.168.10, okay? And it's permitting that. So it's just trying to say, if you're going to be on that address, network address, 192.168.10.x, and look how this works carefully, okay? There's a good concrete example here. Access list 1, permit, allow. Anything with that address with this subnet mask, okay, it's allowing it through on that configure, that R1 interface. Yeah, and this, because of this wildcard here, is like inverse, it's showing you 255 being at the end of it, okay, means any address with that on the end of it there. Okay, and that remark should really show you what this is for, so you know how these things work. Then you use the interface configuration command to select which interface to apply the ACL. So then you choose the interface. It's going to go on the serial. And then you apply the access group to the right interface. Okay. So it was called 1, our particular access list. So look how 1 is referred to here and also here. Okay. So we use the command IP access group 1. Okay. And to activate it, we've got to say in or out. So this actually activates the ACL1 as an outbound filter, I'm calling it out. There. Other examples of specific host. What if you want to deny a specific host and permit a specific subnet? As an example. So I want to say, firstly, I'm turning off the access list one. I'm removing it now. I already did the page before. Gone. Do a new one now. So you've got to turn off the old access list and then start a new one off. Access list 1, deny host 192.168.10.10. Someone tell me what that means now, what we've done so far. What's actually happening with that? What's it doing here?
Can you interpret that for me? PC1.
Yeah, PC1 denied access to where?
PC2.
So what we're saying is we're configuring R1, okay, on this one. And what's happening is it's denying, okay, let's get the right order. See, if you look at the interface being used here, it's got a deny of the host, which is this host. And host, remember the word host, what that means. Yeah, host is to ignore all bits. And permitting 192.168.10.0 with that subnet mask. Okay, there. Let's check this thing here, does that? So repeated it there. 2 examples. So what you're seeing is this permits traffic from a specific subnet 10.0 with a wildcard there. So anything from 10.0 is permitted, okay? But it's denying specifically 10.10. This one's all right, not this one. Okay, and on the interface being applied to it is the serial interface 000 on the outbound filter. So what we've done here is we've deleted the previous version, denied that host. All other hosts on the 192.168.10.0.24 network are then permitted. Okay, that's allowed to move around. We then reapply that to the interface in the outbound direction. 32, right. Denying a specific host and then permit all other traffic. These are just examples of approaches to doing this. So the first statement, again, removes the ACL. Next command denies the host from the PC1 host over here at 10.10. Access 1 list permit any, permits all other hosts to do what they want. Okay, that's applied to G00, which is over here, in the inbound direction. Okay, R1 is only really affecting the 6810 LAN, which is that one over here. Okay, this is being applied to inbound on that, right that point there, okay, that's where this is happening. So it's denying that one from coming out. Yeah, beyond this network. But other traffic is permitted, so the switch can operate. Some syntax, you can name our ACLs with actually names rather than numbers. So rather than using the number 1, you actually can use a word, and the word standard is used here. Okay, this is helpful to make it easy to understand a function of something. There needs to be alphanumeric, case sensitive, and unique. And you also can use the remark command to add more, and that's an example of one being used here actually. That's okay.
It's just like a banner MOTB.
Yes, it is like actually. Remark is a bit like that. It's a bit like having a bit of text in there which allows you to use it. I mean, they named this standard, and then no access, okay, is the kind of thing given here. And it's referred to again down here. So, packet tracer activity to configure numbered standard ACLs. Okay, so here's the scenario. you're going to practice defining filtering criteria and configuring the ACLs in a pre-configured network. You also need to verify and configure the ACLs too. Okay, so this activity now, I'm just going to freeze here, and I'd like to do some configuration of an ACL. And it will be, let's just find that for you where that actually is in the activity. Topology, it's the same one, isn't it? Different diagram, There's two scenarios there, by the looks of it. So let's find you that one. Standard IP4 number is going to be configure. 7215, 7216. Okay, folks, if you want to please look that up, 7216, please. Now, if you want to do a bit of practice for you, okay, there's some interactive activities here beforehand that are good practice. So you can work through those, okay, just to build that up, and then approach this one. It's recommended, okay? Just a couple of these small, short interactive activities that are online apps. And onto the packet tracer here. I'll get this printed now. That's all right. And if you want to take home also, I mean, it's just all the different areas with number and named is simply just so you can have named standard ACL, so it's got a word in there. You know, I don't think it's much difference. Number or name, as long as you use the same thing, you're going to be fine. Okay, so I'll give you 7216 if we start with that. Then after the break, I'm going to go over modifying ACLs, and then there's like an activity beyond that, which is this lab here. Okay,